Hello, this is a brief tutorial on nomenclature for ionic compounds. The first place to start is to memorize the common names for the common cations and anions. These are compounds or ions that we're going to use in the laboratory and in a number of our classroom discussions. Notice that the table is organized by charge. And the best thing is probably to prepare flashcards to remember these ion names. So the common +1 cations are the hydrogen ion, lithium ion, sodium ion, potassium ion, cesium ion, silver ion, ammonium ion, and then copper-1 or cuprous ion. And the reason we have to say copper-1 is that unlike the other +1 cations that we've talked about, copper can exist in two oxidation states. So you'll notice we have copper-1 or cuprous ion, and we have copper-2 or cupric ion. And so to differentiate the two possible charge states, we have to put the Roman numeral or the common name. +2 cations, magnesium ion, calcium, strontium, barium, zinc, cadmium. Notice that we're using the element name followed by ion. Cobalt-2, copper-2, iron-2. These are easy to remember. Manganese-2, and we're going to typically use the Roman numerals to indicate charge state as opposed to the common name. That makes it easier to remember. Lead-2, tin-2, etc. Aluminum always exists in the +3 oxidation state, so the aluminum ion doesn't need a Roman numeral to indicate charge, whereas chromium-3 and iron-3 do. So those are the common cations. Now let's move on to the anions. The common anions, hydride. So that is hydrogen that's gained an electron as opposed to the hydrogen ion that has lost an electron. Notice that the anions end with "ide," hydrogen, ide, or hydride, fluoride, chloride, bromide, iodide, cyanide. So now this is the first one where we're using a polyatomic anion, two atoms to form an anion, and this is named cyanide. Hydroxide, again, another simple polyatomic anion. We have the acetate ion, which is technically an organic anion, but commonly used in many of our laboratory experiments. So you're expected to recognize and know the name of the acetate anion. Chlorate ion, perchlorate. And the differences here, the 8s are indicating a difference in oxidation state. Notice that perchlorate and chlorate describe ClO3- and ClO4-. The oxidation state on the chlorine is changing in these complexes, and that is reflected in the different polyatomic anion name. Nitrate ion, NO3-, is different than nitrite ion, which is not shown on this list, and that's NO2-. And then we move on to permanganate, oxide, peroxide, sulfide, carbonate, chromium, dichromate, sulfate, nitride, and phosphate ion. Those are the common anions, and again, you should memorize these so that you can easily recognize chemical formula and chemical names and interconvert seamlessly. So now when you put anions and cations together to form ionic salts, the charges have to balance. So here I have a table with a series of anions in the column and cations across the row. And as I combine these, the charges have to cancel. So if you combine potassium with chlorine, or potassium cation with the chloride anion, the metal comes before the anion, and so this would be potassium chloride. One potassium, one chloride to have charge balance. Let's do some others. Ammonium chloride. Again, 1 to 1. One ammonium, one chloride to make a neutral salt. Magnesium chloride. One magnesium, but it's a +2 charge, so I need 2 chlorides, so that's MgCl2. Iron chloride, FeCl2. Now we might actually call that iron. The name for this, FeCl3 is the correct formula, but we would name it iron 3 chloride because iron 2 chloride also exists. It wouldn't have the +3 charge, but if you were naming it, you would name it iron 3 chloride or iron 2 chloride. And we'll come down to this last row. This would be ammonium phosphate. The ammonium ion is always +1. The phosphate anion is always -3. And because of the -3 charge, we need 3 ammoniums. Notice the subscript 3 here, designating that 3 ammonias, each +1, are combining with phosphate to give us the neutral salt. And finally, iron phosphate, and we would write this out as iron 3 phosphate, again, to indicate. Okay, well, let's go ahead and do our last ionic nomenclature table. And so here we have cations, anions, formula, and name. And so what you should do is go in and fill in this chart, and I get you started here with a couple of examples. So let's start with lithium oxide. The cation for lithium oxide is Li+. So lithium only has one oxidation state. It is a group 1 metal, so it has a +1 charge. The anion, oxide, is O2-, and so the chemical formula has to balance the charge, so Li2O. All right, what's next? Manganese. So this species, this ClO2, is referred to as chlorite. And chlorite has a -1 charge. So that means that the manganese has to have a +1 charge. There's my chlorite, ClO2-. And because manganese has multiple oxidation states, the cleanest name for this is manganese 1 chlorite. And last but not least, zinc perchlorate. Zinc perchlorate. Zinc has multiple oxidation states, but it is commonly only found in the +2 oxidation state. And so we don't need to say zinc 2 perchlorate. We can just say zinc perchlorate. It's +2. Perchlorate is ClO4-. Again, you know that from memorizing your polyatomic anions. So you need to have 2 perchlorates per zinc to give you electrical neutrality. And so the chemical formula here is ZnClO4-2. And that is the end of our brief introduction to ionic nomenclature.